Hello, everyone, and thank you for joining us today for another Cyber Threat Alliance webinar. My name is Neil Jenkins, and I'm the Chief Analytic Officer at CTA. I think we've got a real treat for you today. My guest is Matt Chiodi from Palo Alto Networks. We're going to talk about Unit 42's recent cloud threat report. Personally, I'll note that I learned quite a bit from this report. Provisioning cloud infrastructure and the supply chains around that are all very new to me. And it's great to see the Unit 42 team publicly talking about cloud security around that. A bit of logistics before we get started. Viewers can ask questions in the Q&A window of the webinar. We'll do our best to get to them in the discussion, but if we don't have time, we'll try and address your questions via email afterwards. So with that, I'll ask Matt to introduce himself, tell us a little bit about his role at Palo Alto, and tell us about what generated this research.
Absolutely. Well, thanks, Neil. I'm looking forward to discussion as well. We definitely have a lot to cover in 29 minutes. We're going to have to move at a fast clip. So Matt Chiodi, I'm the Chief Security Officer of Cloud at Palo Alto Networks. And what we're going to be talking about today is our latest threat research. And I think what's unique about this threat research is a lot of times what's passed off in the industry as threat research is usually just surveys. So I always tell people, anytime you see a statistic, go back and probably all the way at the back of the report and look at how they did it. A lot of times you'll see, we ask people questions, and it's not that surveys aren't useful. It's just that they tell you what people intend to do, not what they actually put into practice. So everything you're going to hear about over the next 20 or so minutes is all based upon hands-on research from our, literally thousands and thousands of sensors across the globe. So in this report, we focused on what has really changed around the cloud native supply chain. And, obviously with the likes of SolarWinds and Kaseya and all those different breaches that have happened, what we wanted to do is we wanted to look at, well, what is the impact from a cloud native perspective? So when people ask us why did we do this? Well, as I mentioned, SolarWinds is kind of really the big reason behind that. What's interesting is that although SolarWinds received the most media coverage of any supply chain attack in history, what most people missed, including myself, is what happened behind the scenes. So I found this quote from their CEO, and take a minute to read this. I totally missed this point here that, he highlights the fact that it wasn't that the attacker got directly into their source code repository and made a change. It was that they got into the automated build environment, which is really just another way of saying their continuous integration or their CI pipeline. So this is something that I had totally missed. And we talk a little bit more as we go through some of the research.
Matt, so for that continuous integration pipeline, that you're referring there to provisioning cloud infrastructure, is that correct?
Yep, we are. There's a couple pieces to that though, and I think hopefully this next slide will really help maybe those that are not as familiar with how cloud native applications are built. Hopefully this will help you just get a little bit of more appreciation for how complex they are, and really why we chose to go through this topic in a lot of detail. So let's start, Neil, with an example of a very simple cloud infrastructure that is built in a very cloud native way. And what I mean by that is it's using infrastructure as code, it's using containers and whatnot. I also want you to take away here that, even a great architecture can inherit many misconfigurations and vulnerabilities from the dependent packages that are used to build it. So let's talk about this. There's generally 3 stages that developers go through at a high level when they're building a cloud native application. So phase 1, which you're looking at on your screen, is cloud infrastructure provisioning. This is where the developers will typically use infrastructure as code. So one that's very popular is Terraform. It works across multiple clouds. It's agnostic to that. It's open source. in this case here, and this is a hypothetical scenario, the developer has chosen to use 3 specific Terraform modules: VPC, that's the networking; Kubernetes for deploying the containerized applications; and then storage. Right now, the storage module is also dependent upon 2 other modules. And then after all 5 of these modules are deployed, we now have a total of 9 misconfigurations that are introduced. And we are only in just provisioning the cloud infrastructure. There's not any actually applications running yet at all at this point. Right. So this is just that base layer.
So where are those misconfigurations coming from? Are they native to the packages that are being used to provision?
It could be, right? So in this scenario here, what very well could be is that because a lot of these packages are pulled from open source repositories, like the Terraform registry, which anybody can upload to, it could be that, it could be completely not with a malicious intent. It could be just, hey, I'm a developer. I created a module that I thought would be helpful. I uploaded it and it contains some kind of security misconfiguration. And then Neil, you download it into your environment, you start using it. That's how these types of things very often proliferate. It's a good question. It's a good question.
And I imagine in one environment, is it possible that it's not bad in one, or not a misconfiguration in one environment, but it could be a misconfiguration in yours?
It could be, because a lot of it then has to do with, do you have compensating controls, right? So that's the other part of this as well. So, all right. So we've just built the cloud infrastructure at this point. The second phase, this is where we start to deploy Kubernetes. Okay. Now, in this case here, the developer has chosen to use something known as a Helm chart. For those who don't know, Helm is really just a package manager for Kubernetes. All right. Now you're going to start seeing this recurring theme here as we go through this of dependencies. Okay. So the main Helm chart that they're using here, it actually depends upon 2 other Helm charts. And then each Helm chart also depends on 2 container images. So you're seeing this multi-layer cake, right? The stacking of the complexity. And then after all 3 of these Helm charts are deployed, we now have a total of 5 Kubernetes misconfigurations that are introduced. So we've got the 9 that were in that base infrastructure level. And now we've just added on 5 more, and we still don't even have an application running yet, right? We're just at that Kubernetes layer. Now in the final phase, this is where things get really interesting. This is where we actually deploy the container image. So here, each container image is instantiated usually to 1 or more containers across a cluster. It depends on the architecture. Inside each container, the application code and all its dependent packages are loaded into memory. And then after, in this case here, there's 8 containers. After they're all deployed, we now have a total of 40 application vulnerabilities that are introduced. So you've got 9 in the base layer of the infrastructure, 5 at the Kubernetes layer, and 40 that were actually in the application code within the containers itself. So what I want you to take away here again is just how vulnerabilities and misconfigurations can very quickly snowball within the context of the supply chain and its dependencies. And remember, this deployed infrastructure, it would be fully functional, right? It would work exactly as you intended, except that the default configurations of all these dependent packages is likely not very secure. And if any one of these dependent packages are compromised, any cloud environment that is using them could be vulnerable to attacks like those we've had in recent history with SolarWinds, Kaseya, and other ones.
Yeah, this is a really good example, and thank you for walking through this. How do you explain the differences between misconfigurations and vulnerabilities in this space? Can you see vulnerabilities in those provisioning and deployment steps as well?
You can. And what I would say here is that, a vulnerability is really anything that an attacker can use to access the application or the environment. So in this scenario, it's likely that the containers have unpatched CVEs. And that's very, very common. I think you'll see a statistic later on here that, we surveyed literally thousands of containers, and the vast majority of them by default have unpatched CVEs, usually critical ones. Now, a misconfiguration in this scenario is anything that was incorrectly set up. So using containers again, as an example. So if the security team, maybe they have a policy that says containers cannot run as root, but then the DevOps team maybe mistakenly deploys a container and they're running it as root. Well, that would be a misconfiguration. So the build doesn't necessarily require a fix as a vulnerability would, but the way it's built exposes this infrastructure to risk. And an attacker would have an easier opportunity to access the data without needing to exploit a vulnerability. That's probably the best way to think about that nuance.
Yeah, that's great. That's really helpful. Yeah, so I mean, just looking at this and the way these misconfigurations and vulnerabilities are just stacking one on top of the other as you're pulling them in, I'm really reminded here of that expression that it's just turtles all the way down, right? But when you start building out this virtual infrastructure, your problems just become like misconfigurations all the way down. So how do you work to secure all of this open source code and containers?
Yeah, I mean, there's a couple ways, and we'll delve into a little bit later on. But the best way to get ahead of this is not through like, hey, we're just going to put like compensating like WAFs and different things like that in the line, right? Certainly, you need those components, but what we have found is most effective is getting back and enabling developers to have tools so that when they're creating these cloud native infrastructures, be it containers, infrastructures, code, you're actually enabling them to create those securely to begin with, right? It's not that you don't want to stifle innovation. You don't want to prevent them from downloading from these open source sites, but you want to create a process by which they can use those, get them scanned, looking for those common misconfiguration and missing vulnerabilities before they deploy them into your environments. That's really probably the best way that we have seen to be effective in combating against these types of threats.
Great.
So this really leads me to really this statement here, right? Which is that open source tools, they're great in that they're open, right? Anybody can scrutinize the code, but what people often forget is that's a two-edged sword. No one's obligated to maintain it or to secure it. And if we look at, some of the most popular modules, some of them haven't been updated in years, right? So if you look at, there's a tool called Artifactory, not the one from JFrog, but there's Artifactory. There's something called FPC Ops. These ones haven't been updated in years.
That's amazing. That's amazing. So I've encountered this in my past work too, right? Where folks want to talk to you about, oh, well, use open source, as if that is a catch-all to being more secure. But if nobody's looking at the code and no one's doing anything about it, then it doesn't make it any more secure than anything else. So I personally, I love a really good red team story. I hear that you have a good one here for this example from the work that your team did. So can you tell us about the engagement you all had with the customer that gave you some real world examples of this complexity?
Absolutely. And this is what really kind of, you can do threat research, but when you actually do the hands-on stuff is when it really kind of comes to light. And so just kind of a quick background, what you're going to see is this really illustrates how a malicious insider could harvest a continuous integration repository to access sensitive information. So this red team exercise, when we were approached by the customer, they didn't say, hey, we want you to replicate SolarWinds. What they said was, look, we want to replicate the SolarWinds attack from the perspective of a malicious insider. Like, what can you do, right? So this is not really an outside in type of attack. This was, I'd say, an inside out type of scenario. So this is typically when we look at kind of the cloud native aspects of this, attackers typically follow a 5-step process when they're attempting to breach a CI pipeline. And our Unit 42 threat researchers took a very similar approach. So we'll go through a couple of these. Again, if you guys want to download the full report, I encourage you to do that. Neil and I are, given time constraints, we're probably covering 20% of what's in the report. So definitely encourage you to download the full report. We'll have a link at the end. So phase one is always about recon. And this is the same with any type of attack, right? You've got to go find out about your target. But with the cloud native pipeline, recon is really about finding, pulling down, and scanning any known infrastructure as code templates, the repositories, and really trying to understand more about your target. In this case here, our researchers, they wrote a custom script to efficiently download every accessible repository that they had access to. And this was an immediate kind of tip off for us that, again, they were given the access that a normal developer would have. And it was immediately relevant to us that this organization, that although most would probably consider their security to be mature, they struggled with separation of duties. This was immediately apparent because our researchers, even at this very early phase, were able to exfiltrate more than 150 unique repositories. So this was something that was like, okay, like this is probably not going to be a long red team exercise to get to the target that we are going for. And most people think, well, this probably doesn't happen, but we've done many of these before. And unfortunately, this is more often the case than not. So step 2 is about initial access. And this is where you take that initial catalog of findings and you start to say, how do I get that foothold in the target's environment? So here our researchers, they gained initial access by leveraging several of the hard-coded identity and access management credentials that they identified during the Recon phase. And this then allowed them to perform additional enumeration operations. And again, there's a lot of ways that an attacker can gain initial access to a system. In the case of cloud native environments, maybe they're getting access through the container management system like Docker or Kubernetes. Any one of those ways could allow an attacker to potentially gain initial access to the cloud pipeline. So step 3, this is where things I think start to get a little bit more exciting, right? So you've got the initial successful compromise of the cloud environment. And now researchers and attackers, they start to look like, what else can I get to in here, right? They already know what their target is, but they may not be able to get there right away. In this case here, our researchers, they were successful in moving laterally, and this allowed them to escalate their access privileges because, again, I think one thing that's important to note is that this customer, they were running on AWS, and every cloud service provider kind of has their nuances, right? In this case here, we used a technique which is known as the IAM pass role technique. And this presented our researchers with additional access to the customer's cloud environment and their CI pipeline. But in general, attackers, they will continually cycle through Recon, initial access, and lateral movement, looking for ways that they can get closer and closer to their desired target. Step 4 is going after exactly what I'm after. Again, in this case here, we're trying to find how do we get to the place where the software itself is being developed, not the core repository, but the systems and processes that are used to process that code. So here we're trying to locate and compromise the CI pipeline, looking for CI pipeline applications like automation servers, things like Jenkins, JFrog, Circle CI. Here, our researchers used identified infrastructure as code templates that I talked about earlier that were located within the repository managers. So think of like GitLab, things like HashiCorp's Vault, and they were able to parse through those to identify the leakage of sensitive information, such as hard-coded IAM credentials. Okay, in this case, our researchers found 26 hard-coded IAM credentials within the infrastructure as code templates, but also looking at things like configuration and log files. All of these types of information are really useful for attackers when they're coming into your environment. The last step is where I can now actually poison an application. And there's typically 2 ways that an attacker, what they can do at this point. 2 ways. Now, in the case of our researchers, when we got to this point, we stopped. We're not going to actually poison anything within our customer's environment. Although certainly if an attacker had gotten to this point, they weren't going to stop and be nice and call the SOC and say, hey, you missed us and we got the flag. But there's usually two choices that they have at this point. They can poison the core application code base. And this is really about going in and modifying the source code to create a backdoor, maybe do a C2 infrastructure. The challenge with taking that direct approach is that vendors very often scan and review their source code for misconfigurations and vulnerabilities very frequently. So that process in itself will sometimes catch it. The alternative path is to go after the support plugins. This is what happened with SolarWinds. Okay. So instead of going after directly the source code, you go after the support plugins, because unlike modifying an application source code directly, modifying support code plugins may allow or could allow an attacker to go unnoticed for a much longer period of time. And that's exactly what happened with the SolarWinds malicious plugin Sunburst. It went undiscovered for a very long period of time.
So this is really great. It's a great case study. So it sounds like, if I can just recap a little bit, it sounds like you were given access as if you were an insider, correct? Yeah. So obviously, I think we can all see where that's bad, and the path that they would take would be one you would want to protect against. I can also imagine cases like in the SolarWinds case where you're coming as the threat actor is coming from the outside in and getting access through the traditional ways and then finding their way into the same pipeline. Is that SolarWinds attack essentially a harbinger of things to come from nation states and APT actors, and maybe even criminal actors in the future?
Absolutely. Yeah. I mean, I think when you look at those types of attacks, what it does is it obviously encourages copycats, right? Other people to say, wow, if they can do this at such a massive level, then I can also do it. And I think what we've seen consistently with our cloud threat research, specifically over the last 3 or so years, is that, and I recently took a poll on this on LinkedIn. I'm curious to see the thing that I asked the question, why is it that you think misconfigurations continue to really hamper organizations as they go into the cloud? But yes, I think that misconfigurations do tend to be the main thing that bog vulnerable organizations down when they move to the cloud, and attackers are aware of that. So I think cloud environments are going to continually be targeted more and more, as at least probably over the next year to 18 months.
So it sounds like, a lot of the thinking you're doing around this is taking advantage of those misconfigurations. But do you see cases where threat actors or criminals may actually try to introduce misconfigurations or find ways to deploy code like miners or maybe even ransomware that sits quietly in these containers waiting for an organization to upload them and provision them?
We've actually seen that. We've done some research sometime in the last, I think it was in the last 18 to 24 months, where we looked at literally thousands of containers that were out there in like the Docker registry and things like that. And we were able to find some of those things. Now, the good news is that obviously we notified like the owners of those repositories, Docker, and they are lightning fast in taking those down. But we have usually in our threat research, we kind of talk about crypto mining quite a bit. We didn't cover it in this report. And I think if I remember the statistic from the last one, when we saw it, it was actually on a decline for the first time in the 4 years that we were covering it. But it's still fairly pervasive in many cloud environments.
Absolutely. So this is a great case study, but as you said, you've got tons to cover here. So do you have data on how bad this is at other organizations?
We do. And so I think just the backdrop here for this is that our researchers, they used a tool from a company called Bridgecrew, which Palo Alto acquired in the last 6 or so months. And the tool, it's an open source tool. It's called Chekhov, named after a Star Trek character, for those of you that watch Star Trek. And what they've done is this tool is used to analyze and look for security issues in infrastructure as code templates, specifically Terraform. And what they did is they downloaded literally thousands of templates from popular open source repositories. And the owners, they can be a cloud service provider, it could be a vendor, it could be an open source developer. And the bottom line here is that most of what's being downloaded from things like Terraform registry has very poor configurations, right? We found that almost half of those modules contain at least one critical or high severity misconfiguration. And if you kind of filter it down to those ones that are most popular, we found that the majority of those, 64%, result in at least one higher or critical misconfiguration. So, again, Terraform is a great tool, right? It's an open source infrastructure as code tool created by HashiCorp. And it is a tool that as security teams, we really need to be, encouraging our development teams to use, because if they can put the infrastructure configuration in code, that means we can inspect it as code, right? So there's an advantage to that. Unfortunately, most of what's being downloaded and most of what's out there today is misconfiguration riddled from a security perspective.
Okay.
One of the other things that we've seen consistently, and there's a lot more data on this in the report, is that as applications build up their dependencies, there's a direct relationship. There's a direct correlation, right? More dependencies, more misconfigurations. One example is that we analyzed one chart that had 23 dependent charts when deployed. And guess where the vast majority of the misconfigurations came from? 92% of the misconfigurations were in the dependent charts. So if you're not scanning down all of those different layers, you're going to completely miss most of those misconfigurations, most of those security issues. So let's look at one last thing here, because I know we're getting low on time, right? So containers are a core component of the cloud native ecosystem. So here our researchers, they analyzed the container images used in Kubernetes Helm charts. They looked at over 1,500 distinct images. This is what I was alluding to. 96% of those images have known vulnerabilities. And if you filter down on just the critical and high severity ones, 91% of those containers have some type of critical or high severity vulnerability.
That's amazing. That's amazing. I mean, are there any ways that security teams can fix those vulnerabilities prior to downloading them? Or once you download them, are you kind of stuck with them in your environment?
No, I mean, there's definitely ways to do that. And really, this is why I say this, right? It's really important that whether it's a DevOps team or whether it's a security team, they've got to have visibility into that full bill of materials. They've got to understand all of the components, right? It's no longer just, hey, a lot of what's being built in the cloud is not, it's not commercial off the shelf. It's on you to understand what's in that. And you've got to be able to have those tools and those capabilities to be able to scan and understand and have that full visibility into the whole workload and the whole bill of materials.
Great. So yeah, why don't you tell us a little bit about what mitigations are possible? Like, how can you correct these misconfigurations? You know, what can teams do?
Absolutely. Yeah. We don't want to just leave you guys sitting there worried, like, oh my goodness, what do I do? So there's really kind of 4 steps that we identify in the report. Number 1 is the Cloud Native Computing Foundation, for the CNCF. They recently released, sometime in the last 6 months, a white paper on supply chain security. So number 1, go out and read that. Make sure your DevOps teams have that. Step 2 is really strategic. It's about setting your vision on what shift left security looks like in your organization. So this means, including the vision, the ownership, milestones, and metrics. The third phase is really where the security team has to do some sleuthing, right? They've got to go out and understand organizational wide where software is being created in the company. This is the who, the people, the process, and the technology part. And last but not least is really where the technology comes in. And that's really more about quality assurance. This is about making sure that every step of the software development process is a place where you can give developers feedback and look for security issues. And there's a lot of open source tools that you can use for that. There's Bridgecrew's Checkov, which we talked about. There's Your YOR, and also Air IAM. Those are some good open source tools that can help with this as well.
Great. This is really good advice. I think it fits well with some of the other general cyber hygiene recommendations that we've seen before, like knowing what your assets are. Does Palo Alto Networks have any products that assist with these mitigations?
We do mention some of the open source tools, which we openly support, but we have our PrismaCloud platform, which really supports an integrated set of capabilities for delivering a holistic cloud security. So we've got our DevSecOps module in PrismaCloud. Again, this is all one platform, one capability, but this really allows organizations to integrate security for their infrastructure as code and their cloud native applications as part of their developer and DevOps workflows. Cloud security posture management. This includes, monitoring your public cloud security posture, detecting and responding to threats, and maintaining compliance for both internal and external compliance frameworks. And then you've got cloud workload protection. And that could be a host, a traditional host. It could be a VM, could be a container, could be a Kubernetes application or a serverless function. This is about securing those across the entire application lifecycle. And then cloud network security, these are about capabilities you can use to monitor and secure cloud networks and enforce microsegmentation across common workload architectures. And last but not least is our cloud infrastructure and entitlement management capabilities. And this is really an emerging area of security, which refers to enforcing permissions and securing identities across workloads in clouds. So all these capabilities are in the PrismaCloud platform. You can check that out. You can go to prismacloud.io.
Wonderful. Well, thanks. So this was incredibly interesting. I think there was a lot of new and good information for me, and I hope our audience got a lot out of it. If you posted a question in the Q&A and we weren't able to get to it, we'll do our best to respond via email. I wanted to thank Matt again for the briefing today, and I want to thank everybody for attending. If you'd like to download the report yourself, you can go to cloudthreat.report/2H21. And it's also, you can also find it at Palo Alto website's Unit 42 website, their blog too, which always has really good research. So thanks a lot, Matt, for briefing today. We really appreciate it. Thanks again for those who attended. If you're interested in learning more about the Cyber Threat Alliance or even pursuing membership, please check out our website at cyberthreatalliance.org. So thanks again to everybody. Have a great day and stay safe.
Thank you.
Thanks.